And I'll request everyone to please go on mute. Okay, so how many of them have joined? I think most of them have joined. Okay, so fair enough. Let's get started. So yesterday, what we were discussing? Last one gets slow. Okay. Guys, please check at your end. Go on. Rutuja, go on mute. Okay, thank you. So we were discussing, yeah, I can remember what we were discussing. So we were discussing slope. I am sharing a screen. Is it visible to you? Yes. Paint window. Okay, fair enough. Thank you. So we were discussing slope. So basically, what is slope? For slope, we are using a formula y2 minus y1 upon x2 minus x1. So, and this slope is also denoted as dy by dx, which is slope is basically in simple terms, if I say rate of change of y with respect to x. The rate of change of y with respect to x. If you change x, how much y is gonna change? That is nothing but your slope. Now, what is y and what is x? So obviously, this is a very simple concept, and this will sink in your mind in the data science. But let's start exploring what is y, what is x. So y is a function of x. Y is a function of x. What does this mean mathematically? This means y is equal to x. F of x. Yes, so y is a function of x is nothing but f of x. But इसका meaning क्या है in simple terms? So my job is to make data science simple for you. Simple terms में क्या है? Yes, that's the perfectly right answer. Y depends on x. Y depends on x. But it doesn't mean that, but x does not depends on y. X does not depend on y. Y depends on x. So in other words, y is said to be dependent and x is independent. Yes. Mera mind pad liya. Good one. Y is dependent, x is independent. Another terminology for dependent is also target. So when I say dependent or when I say target or when I say y, it is one and the same thing. So I can use any of them, any word interchangeably, I can use them. And if I say x or if I say independent variable, they mean one and the same. So I may use any of this terminology. So y depends upon x. And that is why whichever thing depends is taken on your y-axis. So for example, if I want to plot age and height. So where would age come? Will it come on x-axis or will it come on y-axis? X-axis, because height depends upon age, right? Height depends upon age and not the vice versa. But if I have to plot height of the person and weight of the person, then What would be there on Y and what would be there on X? Weight would be there on X-axis. Why? Height would be there on the X-axis because weight depends upon the height and not the vice versa. Weight depends upon the height. So whichever thing depends is taken on your Y-axis, and this is obviously your X-axis, right? So this is the basic mathematics, and when we will do the plot, we would be using the simpler concepts. Now, so yesterday I remember we have taken 2 points. Remember, we had taken 2 points, A and B. Then what did we do? We find the slope. We found the slope, and using a slope, then we found the intercept also, this C also. So yesterday we discussed about M, but what is this C? Normally we say this C as a constant, but this constant is also known as your intercept. It is also known as your intercept. Diagrammatically, this intercept would be denoted something like this. अगर diagram create करेंगे तो ऐसा आएगा. This is your x-axis, y-axis, and obviously they can extend. If this is a line, then what would be the intercept over here? Intercept over here would be, let's say you extend this line. I can extend the line wherever it cuts the y-axis. So this part is known as your C, or the intercept. And from the diagram, you can notice that this C can be negative also, because let's say if this is a line, then intercept would be this thing. And since it is below the x-axis, the y value would be negative. The y value would be negative, right? So this is known as your y is equal to mx plus c. So either you call c as constant or you call c as intercept. Okay, but what does this intercept means in the real life? Real life में intercept क्या मतलब रखता है? Why do we need to have C when we already have M? जवाब बड़ा सिंपल सा आंसर है. Okay, अच्छा, have you ever booked a cab? Cab कभी book करी? Ola Uber कुछ करी? So how do they charge? They charge you for per kilometer. Let's say the rate is 10 rupees per kilometer. Okay. So if you book a cab and if you travel only 0.5 kilometer, what do you think how much you are going to pay? You need to pay some minimum charge. Let's say that minimum charge was 30. And then, so minimum charge was 30 and you traveled 5 kilometers. And for every kilometer you are charged 10. So amount you have to pay is 30 plus 5 into, let's say 10. So you will pay somewhere around 80 rupees. अब समझ में आ रहा है C क्या है? So even when X is 0, there is some output coming. And that is captured using your C. So that is a concept of your intercept. Another thing is, you can also take this sometimes if C is negative. If C is negative, then over there C would act as a kind of threshold. That output would be coming only when the value is above a particular limit. So for example, let's say, let's take an example. I'll just erase everything. Simple example, but it may not exactly fall in the linear regression. Suppose there is a big table. There is a table, a heavy table. And this table will move only when you have applied the weight of 100 kgs or 100, I'll say, let's say you have applied the weight of 100 newtons. So this will start to move when you apply the weight of 100 newton. But let's say you apply the weight only 10 newton. Will the table move? Nahi move karegi. So basically you have to pass this threshold. And once you pass this threshold, then probably you can say, let's say 100 plus mx, or you can say minus 100 plus mx. Now how much force you apply, the distance would be moved, right? So there, that is the concept of your C. Okay? So something like minimum or threshold. Any other doubt in linear regression? I'll not say linear regression, but the equation of straight line. No? Okay. Well, let's talk about correlation. And probably you will realize why data science sometimes becomes little tricky. Why numbers become sometimes tricky. Or why numbers favor you sometimes and they act against you sometimes. So correlation. Correlation is relation between two variables. It is a relation between two variables. Let's say two variables are A, comma, B. So correlation would be denoted as CORAB. The formula for correlation would be covariance of AB into sigma A into sigma B, where sigma is standard deviation of A and sigma B is standard deviation of B. And this is covariance. So covariance is something like variance, but this time we are finding for both A and B. Now, correlation, कोई बता सकता है correlation की range क्या होती है? Range of correlation? Yes, absolutely right. The range is from -1 to +1. इसको note down कर लेना please and try remembering it for your lifetime. कभी आज के बाद भूलना नहीं. Very important. Though it's very simple, but then very important. It is from -1 to +1. We'll see that. We'll explore more. -1 to +1. And over here, I'm talking about two variables. So if correlation is positive, which means if it is greater than 0, अगर 0 से ज़्यादा है, if it is positive greater than 0, it means, it implies both the variables, both the variables move in same direction. Both the variables move in same direction. It means if A is increasing, then B is also increasing. Or if A is decreasing, then B is also decreasing. दोनों साथ में बढ़ेंगे या साथ में घटेंगे. Okay, that is the positive correlation. And I think people have taken a wild guess or wild interpretation that what is the negative correlation. Negative correlation is when correlation is less than 0. It means if one of them is increasing, the other is decreasing. Or if A is decreasing, then B is increasing. They move in opposite direction. They move in opposite direction. एक बढ़ेगा, दूसरा घटेगा. They move in opposite direction. Okay. Now let's take an example. So let's say the best example would be your price and let's say quantity sold. Price and the quantity sold. Let's say price was 100, quantity sold was 50. Price is 140. What do you think? Is it a positive correlation or negative correlation? ये positive है या negative है? अरे बताओ. Negative correlation. Why? Very simple. If one of them is increasing, other is decreasing. Okay. So when price is increasing, do you notice quantity sold is decreasing? So it is obviously negative. Let's do one thing. So obviously, if you want, I can show it you in the Python also, or in, let's say, price and quantity sold. So 100, 140, 180, 100, 140, 180, 90, 50, 45, 50, 50, 45, 40, and then 60, right? 60. So if I want to find the correlation, I can say CORREL and this, this. So it is negative. Can you notice the sign? Minus 1 point, minus 0.9135. So highly negative correlation is there. Okay. Highly negative correlation. And I hope people understand one concept I have purposefully not told yet till yet. So correlation of A comma B is equal to correlation of B comma A, because the formula is very same. Covariance of AB upon sigma A, sigma B. So whether you say correlation of A comma B or correlation of B comma A, answer would always be same. Answer would always be same. So any example of positive correlation? Height and weight. Okay. Yes. So height and weight is a good example of positive correlation. Height and weight. So normally when height will increase, weight will also increase. Age and height. इसमें थोड़ा सा एक कीवर्ड डाल देंगे. Let's say age till 15 years. उसके बाद height शायद रुक जाएगी, right? So or let's say till 18 years or whatever, right? Till a particular limit, yes. When age will increase, probably height will also increase. Any other example of positive or negative? Price and quality of product. So इसको वैसा वैसा बोलो ना, क्वालिटी ऑफ प्रोडक्ट एंड प्राइस. If you will increase the quality, price is likely to increase. Okay, yes. So quality and price. So is it positive or negative? Positive. Okay. Example तो अच्छा है, but example में एक problem है. How would you measure the quality in numbers? Quality को या number से measure करके बताओ. Price I can measure in number. Quality को numbers में कैसे measure करोगे? Example अच्छा है, but how would you measure the quality in numbers? Feelings को numbers में कैसे डालोगे? क्यों डालोगे? Please check करो, someone is unmuted. क्या? राहुल. माइक देख, माइक बंद है. इधर बंद है. ठीक है, but anyway, any other example guys? Time and distance. Positive है या negative है? कैसे? And what about speed? Time and distance same, right? So if I increase the time, then also I can travel the same distance if I increase the speed. So थोड़ा और अच्छा एग्जांपल लो. हाँ, कोई इन्फ्लेशन की बोला था. हाँ बोलो. इन्फ्लेशन एंड ईयर के हिसाब से इन्फ्लेशन बढ़ जाता है. हाँ नहीं, डिमांड एंड सप्लाई विल बी अनदर एग्जांपल. इन्फ्लेशन का किससे कनेक्शन है? So remember, for correlation I need two variables. Inflation is one of them, which is another variable. Inflation versus year. मतलब तुम कहना चाह रहे हो समय के साथ. अच्छा. Inflation and salary. Positive, negative? Negative है? ऐसा मत कहो. Inflation and salary. ठीक है. Are you talking about government sector or private sector? हैं? Data that government publish. कौन सा CMI का data? Okay, so he says inflation and salary. So inflation is rising and salary is decreasing. But salary decrease तो नहीं हो रही होगी. Salary भी increase हो रही है. I got your point. So basically you are saying inflation is more and the salary hikes are less, but still that relation would be positive. ठीक है, दोनों साथ में बढ़ रहे हैं. If you want to put that negative, I got your thought process, then you need to say inflation and purchasing parity, purchasing power. ये मैं मान सकता हूं ये नेगेटिव हो रहा है. ठीक है ना? So the amount of, इसको बोलते हैं purchasing power parity. ठीक है? The how much you can purchase, वो power तुम्हारा कम हो गया inflation की वजह से, definitely. So if inflation will raise, your power to purchase the things will go down. But if you say inflation and salary, obviously this is positive only. ठीक है? अगर ये positive नहीं होगा तो दंगे हो जाएंगे, लोग सड़क पे आ जाएंगे. ठीक है? So I hope ऐसा दिन नहीं आया, but हाँ हो भी सकता है. But yes, so inflation and purchasing parity is going down. Yes, any other example, guys? But trust me, I don't know about government sector, but private sectors, especially in IT, so salaries have beaten inflation many times. अच्छा. Demand and supply, negative. So let me say demand and supply. डिमांड सप्लाई पे डिपेंड करती है, सप्लाई डिमांड पे? जब तुम मुझे एग्जांपल देते हो तो तुम्हारे माइंड में तीन चीजें चलती हैं, लेकिन तुम मुंह से दो चीजें बोलते हो। प्राइस देखो, जैसे तुमने बोला डिस्टेंस एंड टाइम, तो उसमें थर्ड वेरिएबल भी था, स्पीड। डिमांड सप्लाई, देखो क्या प्राइस भी आएगा बीच में? अब क्या कनेक्शन है तीनों के बीच में? हाँ हाँ, तो तीन चीजें हो रही ना। ठीक है। और अगर डिमांड ज्यादा है, हाँ हाँ, प्राइस ऑब्वियसली बढ़ेगा, ठीक है। सो तुम्हारे एग्जांपल्स अच्छे हैं, बट शायद थोड़ा इकोनॉमिक्स में मिक्स हो जाता है, ठीक है, बट एनीवे वेल ट्राइड। ठीक है, लेट्स टेक अनदर, लेट मी पुट सम नंबर्स। और पेट्रोल का किस चीज से कनेक्शन है? फ्यूल का पैसा। एंड व्हाट आर दे? नेगेटिव है किसके अकॉर्डिंग, किसके रिलेटिव है? दो वेरिएबल कौन से हैं उसमें? ज्यादा पेट्रोल डला लो, नहीं खत्म कर। ओके, okay, so I am getting some answers on the chat window. Let me read it out. Siddharth says, as temperature goes up, consumption of cold drink increases. Okay, yes, so that is a good example of positive. More gasoline you put in your car, the further it can go. Okay, positive correlation. The more money you save, the more financially secure you feel. Okay, okay, fair enough. As person invest in economy, higher is the country's GDP. As person invest in economy, the higher is the country's GDP. Invest in economy. Okay, so what do you mean by invest? Is it saving or is it spending? जीडीपी किससे ज्यादा पड़ती है, सेव करने से या स्पेंड करने से? स्पेंड करने से। अच्छा, अच्छा चलो ठीक है। कैन यू सी दिस डेटा? यू हैव टू आंसर वन सिंपल क्वेश्चन, इज देयर पॉजिटिव कोरिलेशन बिटवीन देम और नेगेटिव? आई विल गिव यू वन मोर ऑप्शन, और बोथ, or I'll give you one more option, cannot say. There are four options, 1, 2, 3 and 4, and you have to also give the reason. So if you say if you go with option 1, then why? 2, then why? 3, then why? 4, then why? And here is the data. Don't be in very hurry, take some time, think, and then come up with the answer. and out of these four options, one of them is correct option. ये hint है. क्वेश्चन के साथ उसका हिंट भी दे दिया. See these numbers again. I repeat, you have to choose out of these four options whether it's positive, negative, both, or cannot say. पॉजिटिव है, रीजन बताओ. Okay, so how many people go for positive? सब लोग. पॉजिटिव वाले कितने जाए पे हाथ उठाओ. बाकी लोग नेगेटिव के साथ हैं. पॉजिटिव, पॉजिटिव. ओके, है. वैसे देखा जाए तो है पॉजिटिव भी. ठीक है, लेट मी फाइंड द कोटेशन. Highly positive. So highly positive as in the upper value is 1 and it is close to 1.88. So basically it is positive. Positive correlation, but according to the formula, or you can say mathematically it is positive. Mathematically it is positive. But one of the answer for this can be cannot say also. ये भी इसका एक आंसर हो सकता है. Why? Because I do not know what is variable A and what is variable B. What is variable A and what is variable B. So for example, if I say variable A is runs scored by, कोई इंडियन प्लेयर बताओ जो स्कोर करता है. विराट कोहली. लेट्स से विराट कोहली इन इंडिया वर्सेस ऑस्ट्रेलिया सीरीज. लेट्स से. ठीक है, वैसे 400 रन तो कोई नहीं बनाता है, बट लेट्स से फॉर एग्जांपल इंडिया वर्सेस ऑस्ट्रेलिया सीरीज. ठीक है, एंड वेरिएबल बी इज रन्स. कोई वेस्ट इंडीज प्लेयर का नाम बताओ. ब्रायन लारा. अच्छा चलो ठीक है, बाय लारा इन वेस्ट इंडीज वर्सेस न्यूजीलैंड सीरीज. अब बताओ क्या दोनों में कोरिलेशन है? There is no, probably no correlation. They are two separate teams, two separate venues, two separate years can be. But when you put in data, probably you may see that there exists a correlation. But in real life, correlation probably doesn't exist. In data, you can see that correlation is existing. So the point which I want to highlight is, in many scenarios, make a note of it. When you get high positive or negative correlation, it does not means actually correlation exists. जरूरी नहीं कि correlation exist कर रही हो, but formula will give you some answer. Now you as a person need to think, does this correlation actually exist or it is just a number? Okay, no software can help you over there. Only your thought can help you. Your understanding can help you. ठीक है. And so when you get a high positive or negative correlation, it doesn't mean that every time the correlation or the relation between the two variable actually exists. It may just be a coincidence. इत्तेफाक हो सकता है. It can be just a coincidence. Okay. Another thing is high correlation does not always means that one event is causing another event. So it doesn't. So in the same example, it means when the Virat Kohli will score a century or he will make 400, it doesn't mean that Lara will also score the same run. But maybe for 1 year, 2 year period of time, you might be able to see that kind of relationship. When both were on their peak, probably this type of relationship might have been seen. But you cannot generalize it. You cannot say that every time this will happen. It doesn't mean that one event is causing the another event. Okay. But software will give you an answer. Now it is your thought process, how you interpret it. Your knowledge will come into the picture. Your understanding as a data scientist will come into the picture. Clear? Any doubt, any questions, guys? Okay. Okay, let's talk about distribution. Normal distribution, which is also known as the Gaussian distribution. Now, this normal distribution is marked as highly important. Okay? Try remembering all the properties of normal distribution. Okay? So, normal distribution. Let me before normal distribution, it will look something like this. Bell shape, yes, absolutely right. Bell curve, it will look something like this. Bell. The shape would be something like this. Okay. But before I write a properties, let's try understanding. Let me draw a rough plot and then understand. Is the paint sheet window visible? Visible hai? Okay. Let's say you want to plot the age of the people. And you have done the survey. Let's say you have done the survey on some 1 lakh people, let's say. Okay. You have done the survey on 1 lakh people and you want to plot the age of those people. Now let's say the age of the people would be from 0 to let's say 100 years. It can be more than 100 years also, but let's put a limit as. So this is your x-axis, y-axis. How would you plot the age of 1 lakh people? कैसे plot करना चाहोगे? Yes. So what he's saying is right. So that would be the best way. So what I can do is, so if you want, if you plot the age, let's say age, and this age is going from let's say 0 until 100. If you plot 1 lakh points, then this plot would be very messy. देखने में मजा नहीं आएगा. You cannot make any interpretation 1 lakh points, right? Because software can plot it, but that plot has to be interpreted by a person, and that person would be you in this case. So what I can do is, I can divide this 0 to 100 in some bins. Bins as in intervals. Bins as in intervals. कुछ intervals में break कर देंगे, some logical. So I can say 0 to 10, and then from let's say greater than 10 to 20, and then from 20 to greater than 20 to 30, and similarly it will go from let's say 90 to 100. And for each interval, I can find how many people belong to that interval. Because I know the age of each and everyone, I can easily get the count. So let's say between your 0 to 10 age group, let's say there are some 5,000 people. Between 10 to 20, there are some 15,000 people. And then 20 to 30, there are some 20,000 people. And then 30 to 40, let's say there are some 24,000 people. And from your 40 to 50, let's say the number starts to decrease. It becomes out to, let's say again, somewhere at 21,000 people. So now if I start plotting these things, so the first one would be over here, 5,000. The next one is your 15,000. So the 15,000 bar would be little bigger than the 5,000. थोड़ा सा बड़ा हो जाएगा. So 5,000 I am just saying as 5K, 15,000 as 15K. Then it would be let's say 20,000, 20K. Then let's say it would be 24,000, 24K. And then the values start to, let's say, decrease. And then slowly, let's say, they decrease. Is this plot clear to everyone? Right? So do you notice the values are slowly increasing? They are slowly increasing. And then they are slowly decreasing. Now from the top, if you see from the top, can I say it is taking a shape of a bell? एक घंटी का shape लेता हुआ दिख रहा है, जो स्कूल में बजाई जाती है, right? So this type of distribution is known as your normal distribution. Yes. Normal distribution. Okay. Keep this image in your mind. This image को अपने mind में रखो. And let's come back over here. And let's write down few properties of the normal distribution. In normal distribution, if it is 100% normal distribution, everyone please have a look. So this line, this would be line which would be acting like your mean also and median also. Okay. So in normal distribution, mean is equal to median. It is equal to mod. Mod is most frequent value. Mean equal to median equal to mod. Another property of normal distribution is that normal distribution is symmetric. It is symmetric around mean. तुम लोगों की इंग्लिश मुझसे अच्छी है. Tell me what does symmetric means. Similar to the another half. Yes. So guys, everyone please have a look. एक second यहाँ पे देखो. So this is the line which I am saying is acting like your mean or the median. So symmetric in simpler terms, you can say this line, the red line will act like your mirror. The image on the left hand side and the right hand side would be same. इनको fold करोगे एक के ऊपर एक लैप कर जाएगा. It would be symmetric around the mean, or you can say it would be a kind of mirror image. It is symmetric around the mean. And then obviously you can say it is bell shape, whatever. Bell shape is not actually a property, it is a confusion kind of thing, but still write it down. Now comes a important property. If distribution is normal, then skewness is, बताओ क्या होगी? Skewness would be 0. The skewness would be 0. So there is a formula for skewness, but there is no point discussing that formula. Just remember skewness would be 0. But let's discuss the concept of skewness. What does skewness means? Skewness, why skewness ही define करने जा रहा हूँ. So I want to discuss skewness, not the formula, but what does skewness means. So I'm going to draw 2-3 plots back to back, and the idea of skewness will be absolutely clear to your mind. Let's say this is normal distribution. But not every distribution would be normal. This is another type of distribution. This is another type of distribution. Okay. So let's mark this as normal distribution. A and then B and then C, let's say. Is B normal distribution? क्या B normal होगा? You take any point. If you take whether this point or this line, at any line, is it symmetric around that line? नहीं ना. That means वो normal तो नहीं है. Right? Same thing. You take any line. You try to draw any line on this C graph. Around any line, is it symmetric around that line? No, it won't be. So it is not normal distribution. This graph B, in graph B, do you notice if I draw something like this, let's say, I hope people understand one thing, that values start from zeros and then they keep on increasing. Probably over here, they are moving towards infinity, you can say. Okay. And this is a value 0. And this would be your infinity. Or probably the best thing would be, you can say this is moving towards minus infinity. If the values can go below 0 also. But many times values don't go below 0. So I'm saying 0 to infinity. But it can be from minus infinity to plus infinity also. Now, can someone guess an example of distribution which would be of B type? B type का कोई example सोच सकता है? Species of lion. It is increasing. Tiger increase कर रहा है. समझ नहीं आया. Try taking some better one. Not a very good example. Use of TV decrease हो रहा है. अच्छा, the best example is, let's say, wealth और इनकम. अब जरा सोचो, वेल्थ और इनकम, दुनिया में गरीब ज्यादा है या अमीर ज्यादा है? गरीब ज्यादा है. तो बताओ, गरीबों का चार्ट बी है या सी है? मतलब वेल्थ या इनकम का बी है या सी? गरीबी की बात नहीं कर रहा हूं, बी होगा. सपोज let's say I have done the survey of wealth or the income on the India. ठीक है. Obviously government has this data, so अगर तुमने गवर्नमेंट का डेटा देखा, so इंडिया की पॉपुलेशन है, लेट्स से थोड़ी देर के लिए मान लेते हैं 100 करोड़, वैसे शायद ज्यादा है 130 करोड़. आउट ऑफ 100 करोड़ पीपल, let's say around 80, somewhere around 80 crore people would be earning less than 10 lakh per annum. Right? Am I right? But then there would be some 5 crore people who would be earning between from 10 to, let's say, 20 lakh. There may be some 3 crore people who would be earning more than 20 lakhs. And there may be some 5 lakh people who would be earning more than 100 crore per year. And there would be, let's say, 1 lakh people who would be earning 1,000 crore. And there would be, let's say, there would be 1 lakh people who would be earning, I'll not say 1 lakh, but let's say 1,000 people who would be earning more than 1,000 crore per annum. But अंबानी तो एक ही होगा, ठीक है, या अदानी तो एक ही होगा, ठीक है. दोनों को एक ही कैटेगरी में रख देते हैं, दो रख देते हैं, ठीक है. सो नाउ थिंक, these 80 crore will come over here, right? These 80 crore will come over here, and then these 5 crore people will come over here, somewhere over here, and these 5 lakhs people who are earning more than this thing will come over here, and this Ambani or Adani will come somewhere over here. They will come towards plus infinity. खुद नहीं पता कितना पैसा, ठीक है. So now do you notice it is not normally distributed, but it is skewed. Skewness is there, and it is positive skewed. Why positive skewed? In this diagram, again have a watchful eye, guys. In this diagram, if I draw this diagram, a small diagram once again, can you notice a tail formation is there? एक tail आती हुई दिख रही है. The tail is on the right hand side, right? So this is also known as your right skewed, and right skewed is also known as your positive skewed. ठीक है, इसको ड्रॉ कर लो with an example that income is always right skewed. Number of have-nots would be much more than number of haves. अमीरों की पॉपुलेशन कम होगी, गरीबों की ज्यादा होगी. It is known as right skewed or positive skewed. In right skewed, the major population would be on the left hand side. The major population would be on the left hand side. तुम लोग कोशिश करो नेक्स्ट टाइम तुम लोग राइट स्क्यूड वाली कैटेगरी में हो, आज से 10 साल बाद. So is the concept of skewness getting clear? So in normal distribution, skewness is 0. If it is right skewed, then the tail would be on the right hand side, and it is also known as the positive skew. Now quickly take an example of C. What is left skewed or the negative skewed? उसका एक real life example हो please. एज जो है लेफ्ट स्क्यूड होगी, क्यों? बूढ़े लोग ज्यादा हैं? नहीं. एज, but let's say in Japan, as height increases, temperature decreases. The skewness is a symmetry. So Siddharth, this is the example of which one? Height and temperature. Height increases, temperature decreases. But see, I think some people are still confused. The way he has answered this question, I think people are confused. See, when I am taking the example of normal distribution, I am taking only one variable. I am not taking two variables. Siddharth, in your example, you are talking about two variables. So you can find the correlation, but you cannot say whether the distribution is normal or not. So for example, when I took the example of income, I did not say income versus anything. Okay, it was just income variable. Okay, and the example which you are taking over there, you are having two variables, height and the temperature. Okay. So take an example where if you plot that distribution, you will get this type of graph. ऐसा ग्राफ आएगा कहां पे? Which one? No, there are two variables. Now I'm talking about single variable. Population would be like this. Why? Death rate. That can be taken. Number of people dying versus age. Number of people dying. See, according to me, one very good example. So your example is also right. I can say, let's say marks scored in a easy exam. देखो क्या ऐसा होगा? Marks scored in a very easy exam. So let's say this is 0. This is 100. If exam is very easy, then most of them would have got a very high score. But there might be few who would have still not done that good. Remember last 2 years में सबको 100% आए, 90%, 99% एग्जाम हुआ ही नहीं, but तभी भी कुछ लोग फेल हो गए होंगे शायद, right? So most of them got very good score, but there might be few who might have got less, right? So इसको ग्राफ को ड्रॉ कर लो and write it down to the example. Marks scored in an easy exam. So most of them would have got a very high score, and there would be very few who would have got less score. And do you notice that tail is coming on the left hand side? So it is also known as your left skewed. बड़े simple तरीके से याद रखो, जिधर पे tail होगी वही वाला skewed होगा. If tail is on the left hand side, it is left skewed. If it is on the right hand side, it is right skewed. And this is also known as your negative skewness. Negative skewed. Okay. So can I say this concept of skewness is clear? Mean equal to median equal to mode, skewness is 0. Yeah. Now, let's write the next point. So just to explain this point, I had taken these examples. Let's put the another point. Normal distribution is mesocotic. It is mesocotic, which means kurtosis is equal to 3. I know people don't understand what is mesocotic, what is kurtosis. Don't worry, I'll explain it. As of now, just write it and then let's take it now. It is mesocotic, kurtosis is equal to 3. Okay. Mesocotic. Mesocotic, what does mesocotic means? Where kurtosis is 3. Okay. Let's try taking an example. So kurtosis का एक formula है. If you want, you can see that formula on your own. Not needed also. So जो formula needed नहीं, I'll not put. So can you notice 3 graphs in 3 different colors? If I draw the line, so for all the 3 graphs, the graph in red, black, and blue, do you notice that this green line can act as a symmetry? And probably, so for all the 3 graphs, will people agree that mean is equal to median? The graphs are symmetric around the line, this green line. And probably skewness is also 0. They are ending, right? But are all of them normal distribution? क्या तीनों normal distribution है? तीनों normal नहीं है. ठीक है, all 3 are not normal. But if I talk only based upon these 4 properties, can I say these 4 properties are fulfilled in all the 3 graphs? Yes. Right. But not all the 3 graphs are normal distribution. The normal distribution is only one. That is this black one is normal distribution. This red one is not normal. Why? Because it is kurtosis for this is greater than 3. It is also known as your plateaucotic. And if you come for this one, blue one, this is also not normal because kurtosis is less than 3. Less than 3. It is known as your sorry, my mistake. ये platy नहीं है. This is not platy. This is lepto. एक बार अभी note कर लो, then I'll explain you what lepto means. It is leptocotic. and this is your platycotic. Platycotic. एक बार spelling check कर लेना please net से. Pronunciation will still remain the same, but I might have made some here and there in spell. Okay. So the best way to understand what is kurtosis. Kurtosis is the measure of weakness. Measure of weakness. If values suddenly increase and suddenly decrease, then again it is not a normal distribution. If values increase very slowly and decrease very slowly, then also it's not a normal distribution. Okay. So in this red diagram, do you notice the values suddenly increase and suddenly decrease? Sharp increase and sharp decrease hota hai. So it is not a normal distribution. So when we will build the graph, we will also find a kurtosis. Okay. So if kurtosis is around 3, then it is a normal distribution. Values should slowly increase, and values, I'll not say very slowly increase, but it should increase sufficiently and decrease sufficiently. If values increase very, very slowly and decrease very slowly, then again it is not a normal distribution. Okay. So basically, what is kurtosis? Remember a single line, it is a measure of weakness. How fast or how slow the values increase, that is known as your, that is a measure of your, that is known as your kurtosis. What is 3? 3 is, if kurtosis is around 3, then it is known as your mesokurtic. See, there is one formula for kurtosis. जैसे correlation का formula होता है, वैसे kurtosis का भी formula है. ठीक है? Let's go. देखो, एक काम करते हैं. ये देखो. So someone was interested in seeing the formula. Though I am not recommending it to be remembered, but if you are still interested, this is the formula. ये तुम्हारा formula होगा. This is the formula. ज़्यादा मुश्किल भी नहीं है, चाहो तो याद भी कर सकते हो. This is the formula. What is x? You already know what x is. Remember x minus mu whole square. Mu is your mean, and sigma is your standard deviation. So x minus mu upon sigma whole to the power 4. Okay. So by applying this formula, you will get one answer. If that value is around 3, then it is normal distribution. If it is much higher than 3, it is leptocotic, not a normal. If it is less than 3, again it is platycotic, not a normal. Okay. So if you want, you can try remembering this formula, though I'm not recommending it. No one will ask, and there are some formulas which you can just ignore. Okay. Now let's come back to work. So can I say this point is clear? Yes, clear. Next point. Normal distribution will follow the below results. Within plus minus 1 standard deviation, within plus minus 1 standard deviation, there would be around 67.8% of the data. Within plus minus 1.96 standard deviation, or some people also call it as 2 standard deviation, though the exact value is 1.96. There would be around 95% of the data. This is not date, it is data. Within plus minus 3 standard deviation, it would be around 99.7% of the data. 99.7% of the data. I know people don't understand much. What does this plus minus 1 ST means? What is this? I'll take an example and then probably you will understand. But these 3 properties are mark them as highly important. ठीक है? ये पूछा भी जा सकता है और ना भी पूछा जाए, still you need them. Okay? Try remembering these properties. Okay. Now let's try understanding them by a diagram or by a representation. Okay. Consider you have measured the height of some people, height of people. ठीक है? Mean of the height. Mean of that height. So you have measured the height of the people. Let's say you have measured the height of some 500 people. Okay? You have done the survey on 500 people. Mean was, let's say, around 150 centimeter. Let's say. Okay? 150 centimeter. And the standard deviation was, let's say, 10 centimeter. Okay? You have done the height, you have measured the height of 500 people. So obviously you can find the mean and you can find the standard deviation. Okay? And also consider that this distribution is normal. Okay? The distribution was a normal distribution. Distribution was a normal distribution. So if it is a normal distribution, it would be something like this. Am I right? So mean would be obviously over here. Let's take it as 150. Any doubt till this point? Is everyone clear? Now I am saying standard deviation is 10. What is standard deviation? Can I have a quick answer? An absolutely right answer. What is standard deviation? Deviation from the mean, or I can also say distance from the mean. Okay, I hope one thing is obviously clear to everyone that if mean is 150, it means there would be few people for whom the height was less than 150. And there would be few for which the height would have been greater than 150. And there might be few for whom the height may be exactly 150 also. Maybe. It means, and now go to this property. So within plus minus 1 standard deviation, I am saying plus 1 ST and minus 1 ST. So if I say plus 1 ST, so what would be plus 1 ST? Can I say plus 1 ST would be nothing but 150 plus 10, that is 160? and one standard deviation less than mean would be nothing but 140. Okay. So this is nothing but plus minus one standard deviation. In plus minus one standard deviation, I am saying 67.8. 67.8% of the data would be there. So 67.8 of what? Of थोड़ा जोर से बोलो, एक सही आंसर आया था. 67.8% ऑफ. मेरे को नंबर चाहिए. अरे सिंपल सी चीज नहीं समझ में आ रही है. 67.8% ऑफ द डेटा कौन सा है? 500 है ना. So 67.8% of 500. You have done the survey on 500 people. It means out of 500 people, 67.8% will belong in this region. इसका 67.8% निकालो please. Exact. Tell me the exact number without decimal. 339. Sure. So out of 500 people, 339 would be falling in this region. Idea समझ में आ रहा है सबको? Now let's take one step further. I am saying within 1.696 standard deviation, or for our calculation purpose, I can also say 2 standard deviation. So 2 standard deviation would be what? So what is the mean? Mean is 150. 2 standard deviation would be 20. 150 minus 20 is 130. And 150 plus 20 is 170. So within this interval, how much data would be there? 95%. So let me mark this as green. So will people agree that this green plus red totally includes your 95? Let me say green. Green कैसे नहीं लिखते? Let me say green plus red is equivalent to 95%. इसका 95% कितना होगा? 475. So within this region, out of 500 people whom you have done survey, 475 people would be belonging in this range if it is a normal distribution. And then you can do your further calculation for 3 standard deviation and whatever. Okay? So can I say this third point is also clear? What does these numbers mean using this diagram? So take 2 minutes, write down this point and also draw this diagram so that later on when you are seeing, you can quickly understand. Though I hope it is very clear of this, but still take few minutes and prepare your notes. Okay, can we move ahead? समझ में आ गया? अच्छा, क्या समझ में आया बताओ? शर्मा गया तुमको? Okay, so let's come back over here, guys. Let's have a quick look. Any property which you think is not clear, and try remembering all the properties. आज के आज याद कर लेना and remember them for your lifetime. Never forget. Okay, for a freshers, these properties are important. Maybe asked. So symmetric around mean, bell shape, skewness is 0, normal distribution, this thing, skewness. Okay. So with the skewness, I have also explained what is left skewed, what is right skewed, mesocotic, verticotic, and this thing. Okay. Now. No. So what all things we have seen? We have seen what is mean, what is median, और कुछ देखा हम लोग ने? Standard deviation देख लिया, variance देख लिया, slope, percentile, normal distribution, और कुछ देखा? Correlation देखा, distance देखा, okay. Distance में दोनों variations देखे, Euclidean and Manhattan, ठीक है. So धीरे धीरे topics cover होते चले जाएंगे. I hope people will study. ठीक है, Euclidean and Manhattan. ठीक है, now let's take further step. Okay. Since we have seen this diagram, let's continue from the same point and in continuation, and then probably announce a break also. Okay. So we have seen the distribution. Okay. So in normal distribution, if this is your mean, mu, then within your plus minus 1 standard deviation, within your plus minus 1 standard deviation, you would be having around 67.8. And keep my words, I am saying around. I always use this word around when I'm talking about the distributions, because it may never be exactly, it would be around. Okay. Within, and around क्यों आता है? And within your plus minus 2 standard deviation. Within your plus minus 2 standard deviation, you would be having around 95% of the data. And within your 3 standard deviation on the left and 3 standard deviation on your right, you would be having around 99.7%. Now, अब ध्यान से सब लोग देखना. The points which are let's say which are beyond 2 standard deviation or 3 standard deviation can be taken as outliers. Can be taken as an outliers. Okay. So for example, if I draw the graph of, let's say, marks scored in an exam, and I'm not saying easy exam or tough exam, a normal exam. So the distribution might be normal distribution. It might be a normal distribution. Okay. So let's say this is your mu. So let's consider that most of them have scored between 40 to 95. But let's say 1% or 2% have scored 99 also and 100 also. And there is one person who did not study whatever. Probably he got just 4 marks or 5 marks. So these people and these people can be taken as your outliers. And what is outliers? The values which are far away from the mean. Values which are far away from the mean. But how would you measure that? How much far or how much close? Answer is plus minus standard deviation. If the values are normally 2 standard deviation far or 3 standard deviation far, you can take them as outliers. Okay, isko please note down kar lo. That this distribution, that it can also be used to find outliers. It can also be used to find outliers. Outliers are the event which are rare event, you can say, which are far away from the mean. So using the concept of standard deviation and mean or this normal distribution, I can also find the outliers. Now, whether you want to take 2 standard deviation or 3 standard deviation, there is no fixed guideline. That is your choice. That is your choice. If you take 2 standard deviation, you will have more outliers. If you take 3 standard deviation, you will have less outliers. Okay, since I have mentioned about the outliers and the ways to find outliers, let me discuss one more way to find the outliers. So there are many people from stat background. Can they guess what can be that thing? What hoga? The scatter plot. How can you use scatter plot? कैसे मतलब शायद हाँ हाँ Okay, so you are saying something like this, huh? Let's say, so for example, let's say ये वाला point या ये वाला point outlier हो जाए. So let's say point A, point B, point C can be an outlier, right? Okay, okay. I'll not say a wrong answer, but it's good that you tried. In a way, it's okay also. But the best way would be to use your box plot, which is also known as your whisker plot. People also call it as whisker plot. So this is your box plot. इसमें एक बॉक्स दिख रहा. I am sure सबने ऐसा डायग्राम कहीं देखा जरूर होगा. Something like candlestick formation or whatever. So this is, let's say, point 1, point 2, point 4, point 5, and point 3 would be somewhere over here. Point 1 is your minimum value. 0.2 is your Q1. That is your 25th percentile. Now, whatever you studied yesterday, uski knowledge aaj lagegi. 0.3, can someone guess? It is Q2 or the median, which is also known as your 50th percentile. And this is, I hope people have guessed it, Q3, that is your 75th percentile. And this is obviously max. Okay. This is obviously max. So basically, box plot this diagram to draw quickly and mark all the numbers which I have made and write it that box plot gives you the 5-point information. Box plot gives 5 data points or 5-point information. And what are those points? Minimum, Q1, Q2, Q3, and maximum. Make a note of it, and then we'll see how this concept can be used to find the outliers. इसका use करके outliers कैसे पता लगा? इस क्लास में कोई आउटलायर है? कोई आउटलायर है इस क्लास में? In terms of anything? Height, wealth, weight, knowledge, लगन, कुछ भी? अच्छा ठीक है. So basically what I wanted to ask is, it's not necessary that every distribution may have outlier. Is it necessary that every time we have outlier? Batao. Yes, no, maybe. Yes. So every time we would be having outlier. So that is your assumption. That is your assumption. Let's say if I measure the height of the people in this class, do you think there would be an outlier? Or if I measure the weight? Or if I measure the income? I don't know about income. But so basically what I want to say is it necessary that every time I would be having an outlier? Answer is no. It's not necessary that every time you have an outlier. And and it is a very common thing that every time you may not have an outlier. Okay. But if outliers are there, there can be outliers. But if outliers are there, so suppose, let's say you are measuring the height of the person, height of the people. Let's say the mean was around 150. The standard deviation was, let's say 10. And let's say if there is a person whose height is 210 centimeter, probably this person would be an outlier. This person can be an outlier, right? Right? And 210 can be there. 7 feet, around 7 feet. So some basketball players may be around 7 feet, right? So in this scenario, the outlier is on the higher end side, is on the higher side. But outlier is not on the lower side. But consider if there is a person whose height is around 70 centimeter, then this person can also be taken as an outlier. A full-grown person, I've done a survey on the full-grown person, right? So don't consider about the kids. So this 70 centimeter person can also be an outlier, right? If this person exists, then outlier is on the lower side. If both of them exist, then it is outlier on both the sides. Okay? So outlier may be on the higher side, it may be on the lower side, it can be on the both the sides. Okay? Now, as of now, I have drawn a plain simple diagram. But if outlier exists, and mark my words, I'm saying if It's not necessary that every time outlier may be there. Let's say if outlier is on higher side. For this example, let me say जिसकी height 210 है. Let's say if this person exists, then your box plot would be shown something like this. Your box plot would be shown something like this. There would be one point. Let's say there is one person who is of height 210. Then you will get 1 point on the higher side. So this point, if this point is coming, it means there is one person who is an outlier. Okay? So outlier on higher side. If a person of 70 is there, then it would be something like this. I hope people have already guessed it. A point would be coming down. Outlier on the lower end side. Lower side. If both this 70 and 210 exist, then it would be a points would be coming on both the sides. Outlier on both sides. Okay? And it is not necessary that you always have 1 point. You can have more than 1 point also. So let's say there are two persons who are having height of, let's say there is one person of height 210, another is of 211. Then probably you would be having 2 points over there. Okay? ये समझ में आ रहा है? कोई डाउट है? कोई क्वेश्चंस? Is dependent on? Is it dependent on standard deviation? No. The standard deviation का role होगा, but not. अच्छा, any other question? कोई question आ रहा है mind में? I'm waiting for one question to be asked. What is point number 5? Maximum है? And in this diagram, let's say in this diagram, diagram A, where is an outlier? Outlier कहाँ है? Maximum से ज़्यादा है? Can value be more than maximum? तो फिर उससे ज़्यादा ऊपर कैसे आ रहा है? Mm-hmm. Mm-hmm. Okay. So what you are saying is absolutely right, but my question was little different. My question was the 0.5 indicates the maximum value. So how can the outlier be more than maximum? Question समझ में आ रहा है? ठीक है. So don't answer this question. Let's try understanding in a little different way. See, basically this maximum value is not the actual maximum. It is coming from a formula. And now I am going to introduce that formula because I hope that idea is clear. How can a value be more than a maximum, right? So 3, 4, and 5. If outlier is there, then it would be more than, it would be coming beyond the 0.5. Okay? And if an outlier is there on the lower hand side, it would be coming below your minimum maximum. So outliers on higher side are the values or are the records or the entries which are greater than, and mark my word, I am saying greater than Q3 plus 1.5 IQR. Q3 plus 1.5 IQR. Q3, I hope people can understand. This is nothing but Q3. And IQR कोई मिसाइल का नाम नहीं है. It is interquartile range. Interquartile range is nothing but Q3 minus Q1. Values which are greater than this. See, basically what is Q3? Q3 is nothing but 75th percentile. 75th percentile would always be more than 25th percentile. You take a 1.5 times of that, add it to Q3. If value is more than that, it is outlier on the higher end side. Okay? Values which are more than that. Outliers on the lower side are the values which are less than Q1 minus 1.5 IQR. IQR is again same, Q3 minus. ठीक है, ये है तुम्हारा आउटलायर्स का फॉर्मूला. So how can you find the outliers? There are two ways, classical ways. One is your standard deviation, another is your box plot. ठीक है, try remembering this box plot also. And anyway, we are going to when we will do our plots, we will plot all these diagrams. So again, there would be a revision. Okay, so I think the time has come to announce the break. कितनी देर का break चाहिए? 20 minutes. So it is 10:50. Take your break till let's say 11:10. कुछ चाय वाय पी लो. Okay, so I think everyone is back. So let's get started. Okay. So people are still joining. Okay, I hope everyone has joined. Oh. So let's continue where we have left stats. Transformation of data. So normally we do two types of transformation. One is a standardization. Now, since you understand what is mean, what is the standard deviation, and another is you can say normalization, which is also known as your min-max scaling. It is also known as your min-max scaling. Standardization, normalization. So let's discuss about them, and we will discuss in two ways. Two ways, and then we will see the formula, and then probably what's the benefit you get if you transform the data. So in standardization, I use a formula which you are a little bit aware of. We use the formula x minus mu upon st. What is mu? Mu is nothing but mean, and st is your standard deviation. In normalization, I use this formula x minus x min upon x max minus x min. This is the formula. Please make a note of these formulas and try remembering them. Important formulas. X minus x min upon x max minus x min. And this is x minus mu upon st. So what does transformation means? And there can be another type of transformation, that is your log transformation. Log transformation. Another type of transformation, log transformation. Right. Is Excel sheet visible to you? Okay. Let me say this is the original data. And let me put some numbers. Okay. Let's say this is income in dollars. Income in dollars or whatever, or thousands of dollars. So what would be the mean over here? Mean over here is how much? 174.875, or let me say what is the standard deviation over here? The standard deviation is this much. Okay. If I want to standardize this data, then I'll use this formula x minus mu upon st. So I have mean, I have standard deviation. Let's apply this thing. So standardization. So what I'll do, I'll say equal to, remember yesterday we have find the standard deviation x minus mu. So same thing, I will say 140 minus. Okay. So B2 minus B12. But यहाँ पे B12 पे ना $B लगा देते हैं. Otherwise values will keep on shifting. Divided by the standard deviation. $B, $40. कुछ प्रॉब्लम हो गया? 1 second. 13 होना चाहिए था ना? By mistake मैंने नीचे वाला क्लिक कर दिया. Okay, and then I'll just drag it. समझ में आया सबको फॉर्मूला? ठीक है? So the same formula x minus mu upon st. So basically 140 minus 174.875 divided by 38 point this thing. Then 140 minus 174 divided by 38 point something. Then 134 minus 174. Then 200 minus this divided by this. So this is the standardized one. Now, this is the data which you are getting after standardization. Do you notice that some values are positive also and some are negative? Kuch dikhta hai? And why some are positive, some are negative? Answer is very simple, because of the nature of the formula. I am saying x minus mu. Now this, for some of the values, this x would be less than mean, and for some of them it would be greater than mean. So it means the answers would be positive also and answers would be negative. So दोनों आएंगे, ठीक है ना? Now let's find the standard deviation and mean for the this new data. So I'll say equal to, वैसे मुझे पता है इसका आंसर क्या आने वाला, but फिर भी I'm just putting the formula 0. Mean is 0. Standard deviation is 1. Okay. Now, up make a note of it that whenever you standardize your data, the new mean is always 0 and new standard deviation is always 1. So property of the data, after standardization. After standardization is mean will always be 0 and standard deviation would always be 1. So this standardization is also known as your Z values. Later on we'll see what Z values actually means. Z values. So it would always be 0 and 1. And mean has to be 0 because you are saying x minus 2. Okay. So basically, if you notice one more thing, the values which were ranging from, let's say, the values which were of higher order, can you notice they have shrunk in a very small range? एक छोटे से range में आ जाती, and the new mean becomes 0 and standard deviation becomes 1. ठीक है? Are you guys able to connect? Check karo please. Is it visible? Is it visible? Whatever I'm typing दिखता है? क्या type किया है? ठीक है, ठीक है. So it is visible. So fair enough. So let's say when I want to normalize my data. सबने join किया or should I wait? Wait. Okay. Okay. Let me know once you are able to join. अंधेरे का फायदा उठा के सो मत जाना, अदरवाइज सब ये सब खोल देंगे. Okay, I think people would have joined. Okay, so normalization. In normalization, what is the formula I'm using? I'm saying x minus x min upon x max minus x min. Okay, so normalization. So what is the minimum value over here? What is the minimum value in the original data? Can I say minimum value is 134. What's the max? 250. Okay. What is max minus min? This minus this. So 116. So in this formula, the denominator will get fixed. This would always be 116 for this data point. And only thing is x minus x min will keep on changing. X minus x min will keep on changing. So I can say equal to, what is the minimum value? 134, right? So let's say x minus x min. Na? So equal to this minus 134. Let me put one more bracket. Divided by how much? Kitna tha? 116. And pull it over. Do you notice that all the values are within 0 and 1? क्या सारे values within 0 and 1 है? None of the values is more than 1 and none of the values is less than 0. And why this is happening? Because of the nature of the formula. I'm saying x minus x min. So x minus x min upon x max minus x min. So this thing will become 1 when x is equal to x max. Am I right? ये 1 तब हो जाएगी when x max and x are same. And this will become 0 when x is equal to x min. ठीक है ना? And probably you will see the same thing. It is becoming 0 when it is the minimum. And it is becoming maximum. It is becoming when it is maximum. ठीक है ना? So, but let's find the new mean. What do you think? New mean would be 0? Mean 0 आएगा? Can mean be 0? अरे बड़ा simple answer है. It would be no. Why? Because if mean has to be 0, then some values have to be less than 0. Since all the values are more than 0, mean cannot be 0. Clear? So mean can be anything, but still if you want to find the mean, I can say equal to average. So mean can be anything as of now between 0 and 1. क्या standard deviation 1 आएगा? नहीं आएगा. Why? Because for standard deviation 1 to अगर 1 होना तो mean should be around 0. So STDEV and the standard deviation is around 0.334. So please make a note, when you normalize, mean will not be 0. The standard deviation may not be 1, but all the values would be within 0 and 1. All the values would be within 0 and 1. All the values would be within 0 and 1. So in normalization or in min-max scaling, what is the nature of the data? Nature of the data is that all the values are within 0 and सारे numbers 0 and 1 के बीच में आ जाए. Any doubt, any question? कोई डाउट नहीं? अच्छा, let me ask one question. what is the main purpose or advantage or benefit we get, or rather you will get, after normalization or standardization? क्यों करना है? If I want to do, I can apply this formula, but what's the benefit you achieve, or why do you wish to normalize or transform your data or standardize your data? सोचो. There should be no error.
Sir, less variation.
Less variation. Okay. How? पहले no error वाले पे आते हैं. What do you mean by error?
If you are doing something, it's leading some problem. Then you should divide in some part and then give advantage in calculation.
Okay. Okay. Thanks for answering, but ठीक है. बड़ा भटका सा आंसर है, but at least answer ठीक है. And you are saying less variation. How?
अगर डेटा मतलब ज्यादा वेरिएशन होगा तो एरर बढ़ जाएगी. जितना.
But what do you mean by error?
Sir,
क्या? Anomaly detect करने के लिए. But anomaly detect करने के लिए standardize क्यों करना?
So it is not huge. So if the numbers are huge, we take our extra understanding. Understand how data is, how big data is, and simplify it. So in this way, we can simplify the data, which will be easy to visualize and understand.
बड़ा लंबा आंसर दिया. ठीक है. तुमने मुझे भटका दिया. ठीक है. बट चलो ठीक है. एटलीस्ट उसने आंसर किया, कुछ रखा उसने. So I am getting one answer on the chat. Better execution is guaranteed, which can be connected to the point. So that says, as information bases become lesser in size, the goes to the information turns out to be quicker and more limited in this way, improving reaction time and speed of workflow. तो सिद्धार्थ ने भी मुझे थोड़ा भटका दिया है. बट ठीक है सिद्धार्थ, आई लाइक योर इंग्लिश. ठीक है. लेट्स टेक एन एग्जांपल. अभी तक राइट आंसर नहीं आ रहा है. किसी ने यूज करा है स्टैंडर्डाइजेशन नॉर्मलाइजेशन किसी अपने कभी एनालिसिस में? करेक्ट. एंड व्हाट वाज द रिक्वायरमेंट? क्यों करा था?
डेटा नॉर्मल है कि देखो.
उसके लिए स्टैंडर्डाइज क्यों करना? वो तो आप नॉर्मल प्लॉट कर लो, पता चल जाएगा. सी आई टेल यू वन थिंग.
अगर डेटा में कुछ मतलब मल्टीपोलैरिटी वगैरह है उसको
मल्टीकोलिनियरिटी. See, I'll tell you one thing. If data is not normal distributed, so whether you standardize or whether you do min-max scaling, it will still remain not normal. ऐसा नहीं है कि if you standardize, then a data which is skewed will become normal. No, it will not happen. So if you are saying that it is used to check whether data is normally distributed or not, then probably कुछ गलती हो गई शायद वहाँ पे, जिसके लिए भी किया. So I can answer this question directly, but before I answer this question directly, तुम लोग अपना thought process build कर लो. Let's take a similar example which I have taken yesterday. Remember, I have taken one example where I had income and saving, correct? And there were two people. अब मुझे income तो याद नहीं कितनी रखी थी मैंने कल. कितना? नहीं रुक जाओ, मैं numbers थोड़ा सा cook करके डाल दूंगा. This time let me take the age also. ठीक है. Let's say income is 13,000. 3 लोग होने चाहिए ना. Let me take a person C. Okay, let me ask the same question. Which person is more similar to person A? Is it B or C? बताओ. अब मुझे पता है तुम्हारा माइंड सबसे पहले डिस्टेंस कैलकुलेट करने के लिए जाएगा, राइट? करो. And why? अगर तुम बोलते हो B, then why B? If you say C, then why C? कौन होगा सिमिलर? Let's say this is age. This age is in years. ठीक है? And income is in dollars or rupees, whatever. कौन सा ज्यादा सिमिलर है? So you can find a distance between A and B, and you can find a distance between A and C. Distance यहाँ पे कम होगा, वो similarity ज्यादा होगी. So what is distance between A and B? Distance between A and B would be 18,000 minus 13,000 whole square. That is your 5,000 whole square plus 5,000 minus 5,500. So this is 500 whole square plus 28 minus 25. That is your 3 square, right? So whether data is in 2 dimension, 3 dimension, the way you calculate would still remain the same. Distance between A and C. 13 and 12 का difference कितना होगा? 1,000. And अब देख के ही लग रहा है कि A and C का distance कम होने वाला है. 5,000 and 7,000 is 2,000 whole square. 25 minus 20 is 5. So which one is less? Which one is more? Obviously, this one is much lesser than A and B. Why? Because वहाँ पे 5,000 का square आ गया, which is a very big number compared to 1,000 square. इतना तो लोगों के समझ में आता है ना? that 5,000 square is still bigger than your 1,000 square plus 4,000 square, right? So 100 square is bigger than, ठीक है? So भाई same चीज मैंने यहाँ पर. तो क्या लगता है सी सिमिलर है, बट क्यों? अगर एज वाइज देखो तो सिमिलर नहीं. There is a big difference of 25 and 25 का difference है, उधर 3 का difference है. And if you see the saving wise, again similarity is less. But if you compare the income, then probably C is more similar to A compared to B. फिर से सुनो and take a hint from there. And remember, the question which you need to answer is, what is the main purpose of standardization or normalization? उसको connect करो यहाँ से. Again, I'll repeat my statements till that idea gets into your mind. If I compare the age, then probably B is more similar. Yes, because difference is only 3 between A and B, and difference is 5 between A and C. If I compare them based upon these savings, again B is similar. Difference is only 500 between A and B, and between A and C it is 2,000. So based upon saving and age, probably B is more similar to A. But when I introduce the third parameter, that is the income, C is more similar to A. And finally, क्या आंसर आता है? Final answer comes out to be C only. But for the two parameters, B is similar. On that savings and age, B is similar, but final answer is C. ऐसा क्यों हो रहा है? Age cannot be calculated. Income and salary. क्यों नहीं कर सकते?
Data is not in same format.
Data is not in same format. Okay. थोड़ा अपने आंसर को इम्प्रूव करो, सही आंसर आ जाएगा.
Data मतलब consistency.
डेटा में कंसिस्टेंसी नहीं है.
Same format or same.
तो तुम्हें क्या लगता है जो 20 इयर्स का पर्सन है उसकी एज, उसका इनकम 12,000 नहीं हो सकती है? कुछ कर रहा हो पर क्यों हो जाएगा? हमेशा नहीं होगा ना, हमेशा नहीं होगा. It can be. So it can be. So let's say when age is increasing, देखो income increase हो रही, तो डेटा आर्टिफिशियल तो नहीं है. सेविंग इज समथिंग रेलेवेंट. ज्यादा खर्चीला इंसान चला गया किसी क्या कहते हैं कसिनो खर्च कर रहा है. आंसर बड़ा सिंपल है. आंसर इज, डू यू नोटिस दैट इनकम is in 5 digits, saving is in 4 digits, and age is only 2 digits. So when you will find, so basically, do you notice the units of income, savings, and age? Units of income and saving तो same है, that is your dollars. But age की यूनिट क्या है? Age की यूनिट is years. Am I right? So now income is in 5 digits, saving is only 4 digits, and age is in 2 digits. So even let's say instead of this 25 and 20, instead of, if I change it to, let's say if I change it to this as 100. Still, C would be more similar. करके देख लो. If I change the age of C from 20 to 100, then 25 minus 100 is 75. So instead of 5, it would be 75 square over here. But this number is still much smaller than the this upper number. So even if I change this age to 500, then also C would be more similar. Suppose करो एक आदमी जो 500 साल का है. Now would you still say that person C is more similar to it? Logically तो नहीं है. But using the formula it will come out. And why this is happening? This is happening because your different variables are measured in different units and they are in different range. अब जरा सोचो, if you standardize them or if you normalize them, all of them would be between 0 and 1. For example, let me say this above data which I have. Income क्या थी बताओ? ABC की income was 13, 18 and 12. So this time let me say I am measuring income in thousands of dollars. I can measure income thousands of dollars, right? No one can stop me. So 13, 18 and let's say 12. Then what was the savings? Savings was 5,000, or let me say this is also measuring in case. So 5, 5.5 and 7. And age is 25, 28 and 25, 28 and 20. Now do the calculation. देखो क्या आंसर चेंज होता है. क्या आंसर चेंज हो जाएगा? Probably it may become very close. शायद अभी भी C को advantage होगी, but now what would be the distance between A and B? Distance between A and B would be 18 minus 13 whole square, that is your 36 plus 0.25 plus this is your 3. 3 is nothing but 9. अच्छा 18 minus 5 25. Okay. So this would be 25. ये तो 0.25 ही रहेगा. Distance between A and C would be 30 minus 2. It would be 1. Then 4 and then 5. That would be your 25. So do you notice this distance is around 29 and 30. ये AC का distance 30 आ जाएगा. And this distance would be how much? So 34. And let me say, अगर ये चीज यहाँ पे instead of 18 had it been 17, let's say, तो change कर जाता. Had it been 17, then this thing would have been 13 minus 17, that is your 4 square, right? 16. 16 plus 9, 25, 25.5 आ जाता. You notice? So instead of saying 13,000 and 17,000 and 12,000, if I take in 1,000, then C is more similar. If I take the actual numbers, then C is more similar. If I measure it in thousands, then B would be more similar. So do you notice one thing, that units are playing a role? अगर मैं units change कर दूं तो data पलट जाता है. Same thing, I am measuring the age in years, but I can also measure age in months. So if I measure age in months, then the age of C would be 20 into 12. Or if I measure the age in days, then it can be this thing. Now, if you do the calculation, probably B would be more similar. Are you getting my point? Because 20 into 12 into 365, when you take a difference from this thing, then the difference would be how much? Difference would be 25 minus 20 is 5. 5 into 12 into 365. You will take the square of this. और यहाँ पे जब स्क्वायर लोगे, it would be, I'll not say यहाँ पे, but over here when we take the square, it would be 3 into 12 into 365. So now this number would be much bigger than this number. Are you getting the point? So do you notice when I change the units, my calculations will also change, or my interpretation will also change. Interpretation will change. जो चीज पहले सिमिलर थी अब डिसिमिलर हो सकती है, right? Now keep that thing in mind. Keep what in mind? Keep that units play a role. Will everyone agree to this point? बताओ. Units play a role? Yes? Now come back to this question and answer this question. Units का कुछ रोल था. अच्छा, I can see some blank faces. लोग अभी भी कनेक्ट नहीं कर पा रहे हैं, शायद मैथ्स थोड़ा सा भूल गए टाइम के साथ. Tell me what is the unit of speed? Or let me say speed बहुत complicated हो गया. What is the unit of, ठीक है, एरिया का यूनिट भी छोड़ दो, पहले मैं डायग्राम बनाता हूँ फिर तुम. Let's say there is a square box of 2 meter and 2 meter. What is the area of this? 4 नहीं है, 4 meter square. 4 meter square है, right? तुमने सिर्फ 4 meter क्यों नहीं कहा? 4 meter square क्यों कहा? 4 meter square is the right answer, I agree. But meter square क्यों कहा? Why? Because units be, when you divide something, units get divided, and when you multiply something, units also get multiplied. So for example, what is the unit of force? Force is equal to mass into acceleration. So the unit of mass and acceleration will also multiply. Mass का unit क्या होगा? Let's say kgs. और acceleration का unit? Meter per second. ms minus 1. So unit of force would be kg ms minus 1. Huh? Second square, okay? Second square, ठीक है. Yes हो जाएगा. Now, so basically ये idea clear हो रहा है that units multiply and divide. अब दिमाग लगाओ. Standardization and normalization. Take a minute and let me know this thing. ये छोटे से आइडिया के लिए इतना टाइम लग गया. So basically you have to answer this question. What is the main purpose of standardization or normalization?
It is not, the value will be higher in the standardization.
You are saying something, क्या? Please एक बार repeat करो, मैं सुन नहीं पाया. So some.
Standardization property is like we comes 0. Standardization comes 1. So the unit is not like the differentiated unit system. Like now they come box. If they are not in similar ways, the value won't be between 0 and 1.
Okay. Right direction में तो है आंसर, but proper नहीं आया. Anyone else? डेटा तो पहले ही सिंप्लीफाई हो गया, उसके बाद मैंने क्वेश्चन पूछा व्हाट इज द मेन एडवांटेज. अरे लोग पिक नहीं कर पा रहे हैं, बट एनीवे if age is in years, let's say if age is in years, then what would be the mean? Mean would also be in years, right? मीडियन भी ईएस में ही होगा, स्टैंडर्ड डिविएशन भी ईएस में ही होगा, राइट? सो व्हेन यू स्टैंडर्डाइज दिस, you have x minus mu upon st. what is the unit of x? Unit of x over here would be ES. Mu की भी ES and standard deviation की भी ES. तो अगर ES ऊपर में common ले लिया, so let's say mean was 10 and standard deviation was 3, then you can take the year common और नीचे का भी year common. So do you notice when you apply this formula, data becomes unitless. कोई unit ही नहीं रहती उसकी. ठीक है? Let's apply the same thing over here. X minus X min upon X max minus X min. The unit of max would also be years. Min की भी वही same होगी unit. यहाँ पे भी same unit होगी years. यहाँ पे भी same unit होगी years. So again, all the years will cut down and again it will become unitless. So do you notice when you standardize or normalize your data, data becomes unitless. And if data becomes unitless, the impact of unit will all obviously vanish. Okay? So please make a note. The main advantage is to make your data unitless. ये तुम लोग को शायद बताया नहीं गया. ठीक है? The main advantage is अगर कोई पूछता है तो standard answer is unitless. Because units play a role. Units play a role. If you want to get rid of the impact of the units, standardize or normalize your data. और अगर किसी को नंबर्स फर्जी दिखाने हैं तो यूनिट्स लेके आ जाओ, वो भी एक तरीका है. कुछ तुम्हारे मैनेजर्स ऐसे भी हो सकते हैं जिन्हें ज्यादा नहीं पता होगा, तो उनको थोड़ा ट्विस्ट करने के लिए ये भी कर सकते हैं. लेटर ऑन जब हम लोग मॉडल बिल्ड करेंगे, आई विल टेल यू द टेक्निक आल्सो कि कैसे नंबर्स अपने फेवर में दिखाने हैं. जैसे गवर्नमेंट दिखाती है ना अपने फेवर में नंबर्स, तो वैसा हम भी कर सकते हैं. ठीक है, लेकिन सच्चाई अंदर ही अंदर पता रहती है. ठीक है. हाँ बोले. Can minimize null values by using normalization. Is this a question? Can minimize null values by using normalization. Can minimize null values. So Siddharth, I'm not able to understand your question. Can we minimize null values by using normalization? No, null values. So null values is something different. Okay. So as of now, I'll not answer this question because I haven't taught what is null values. Okay. So null values have to be taken care of separately. Okay. We'll see that when we'll go to the null values. Okay. When we'll read our data, null values will be there. We'll see how to handle the nulls. Okay. So just hold on to that question for, let's say, one more month. Okay. So answer is to make your data unitless. अगर data unitless होगा तो unit का कोई impact भी नहीं होगा. And one thing which was quite obvious, मैं सोचा था लोग guess करेंगे. So income, let's say a person can so let's say a person can earn $140. Yes. Person can earn 145 also, 250 also. But person can earn minus 0.899. क्या ये अर्निंग हो सकती है? नहीं, right? ठीक है. So let's say when you say a person is earning $140, ठीक है. Now this 140 is represented as 0.51 after normalization. So again, the number doesn't make much sense. But to get rid of the units, what I've done is I have normalized. ठीक है ना? To make your data unitless. So when you make your data unitless, घर पे जाना, इस data को unitless करना. Though this data, the numbers are very, I have just taken 3 records. But if you normalize this data, then probably you will get a better answer. ठीक है? क्या करें, क्लास एंड कर रहे हैं क्या? और चलो ठीक है, एक 5 मिनट और करते हैं। एनीवे क्लास टाइमिंग कितना, 12:30 तक है ना? हाँ ठीक है, सो लेट्स कंटिन्यू फॉर few more minutes and then tomorrow we'll, कल भी है ना क्लास? ठीक ठीक। So tomorrow normally on Saturday Sunday I'm getting late, I'm not able to come by 8:30, but tomorrow I would be there by 8:30, ठीक है? I would be there by 8:30, so 8:30 yes। So जो लोग सोच रहे हैं कि सर हमेशा लेट हो रहे हैं, तो मंडे के लिए वो assumption हटा दो, मंडे I would be there in time, ठीक है? और क्लास थोड़ा टाइम पे स्टार्ट करेंगे। So there is another normalization thing, sorry, another transformation. Let's quickly discuss that. That is your log transformation. Log transformation. Okay, so if data is not linear, let's say, okay, if data is not linear as in, so it is not in straight line. So a straight line can be any format, right? It can, a straight line can be anything. But if data is not linear, if it is not a straight line, then probably it would be kind of curve. Am I right? It would be curve. That curve can be anything. It can be, let's say, curve like this, or like this, or like this, or like this, like this. Kuch bhi curve ho sakta hai, but it would be curve if it is not a straight line. Okay, na? So if data is not linear, then it would be having some curve. Curve may be sharp, may not be sharp, whatever. Now, suppose, let's say my data is something like this. Obviously, it is non-linear. It is non-linear. Now, on this non-linear data, okay, on this non-linear data, let me put some points. Let's say point A, point B, C, D, E, F, G, H. On this non-linear data, try answering one simple question. Compare it with this thing. Let's say this is a straight line. On this straight line, slope is always fixed, right? Slope is always fixed. But come on this part, on the diagram A. Is the slope fixed? Kya slope fixed hai? Answer is no. And those who are not able to understand why no, then let me explain them quickly. Let's say you have this type of thing. So between your point A and B, do you notice you are moving down? So slope is likely to be negative. Between, let's say, this small point C and D, this small segment would be parallel to your x-axis. Slope is likely to be 0. And then let's say when you move from E to F, then do you notice when x is increasing, then y is also increasing? X ऐसे increase हो रहा है और y ऐसे increase हो रहा है. Then slope is likely to be positive. ठीक है? So at every point you take, slope will keep on changing. अगर maths याद आती है, then you will realize that if you take a circle, for a circle, what is the slopes? It has infinite number of slope. Slope at any given point is nothing but when you draw a 90 degree to the tangent. याद आता है? Tangent is the line which is just touches the surface, right? So on this, in this diagram, distribution is non-linear and slope is not fixed. It keeps on changing. It keeps on changing. Now tell me, is this idea clear before I go into log transformation? ये idea clear है? Slope continuously change हो रही. Now answer one simple question. If slope will keep on changing, then what will happen? अगर slope change हो रही है continuously, तो क्या problem आएगा? डेटा कांस्टेंट नहीं होगा. ओके, एज अ ह्यूमन बीइंग के लेवल पे सोचो, तुम्हें क्या प्रॉब्लम आएगा? डिसीजन लेना टफ होगा. परफेक्टली राइट आंसर, यस. डिसीजन मेकिंग वुड बी टफ. डिसीजन मेकिंग इज टफ. वेरी वेल आंसर्ड. सी गाइस, रिमेंबर linear equation, y is equal to mx plus c. If value of m is 5, x, and let's say c is 2, then I know that when x will change by 1 unit, y will change by 5 units. Why? Because m was fixed. But if m keeps on changing, then rate of change of x, the impact on y will also keep on changing. So it means the impact of x between A and B would be different compared to impact of x between E and F, because slopes have changed. So if slope is changing, इसको note down कर लो, relation between x and y is not fixed. It keeps on changing. It keeps on changing. And since the relation keeps on changing, decision making becomes very tough. Since it keeps on changing, decision making becomes very tough. And that is why in economics, most of the time they assume it to be linear. Actually वो linear नहीं होती, but उसको हम assume कर लेते हैं, so that I can take a decision. And that is why you lead it into number of problems. यही same problem पिछले साल कोविड में आ गया था. गवर्नमेंट की एजेंसीज ने लीनियर समझ लिया उसे, लेकिन वो एक्सपोनेंशियल आ रहा था और तैयारी नहीं थी. Is this idea clear? So if it is not linear, then slope will keep on changing, and if slope will keep on changing, relation is not fixed, and if relation is not fixed, taking the business decision is problematic. To help that problem comes your log transformation. ठीक है, comes your log transformation. एक काम करते हैं, थोड़ा सा बड़ा लिख देते हैं. Okay, so normally what is a linear equation? Linear equation is y is equal to mx plus c, right? But let's say if it is non-linear. अगर non-linear है, then equation is represented as y is equal to m e power kx or m e power cx, whatever. M e power kx. What is e? E is nothing but your exponential. That is your natural log. The value of e कितना होता है? Value of e is normally 2.7183 continued होती है. If you go to the Google and say what is the value of e, it will give you the same. So, and what is m? M is a number. What is k? K is again a number. So, for example, your m is mapped to your m, and this c is mapped to your k. C भी एक number था, k is also a number. Now, this is your exponential relationship. I will take a log on both the sides. Ln y. What is ln? Ln is nothing but log base of e. Log of base e. Log of base e. So I'll take ln y is equal to ln m e power kx. So I have taken log on both the side. Any doubt, any questions till this point, guys? बताओ, कोई doubt है? Clear है? So I have taken log on both the side and base is e. ठीक है, जिन लोग को log में थोड़ा सा प्रॉब्लम है, एक बार घर पे जाके हल्का सा एक्सप्लोर करो व्हाट इज log. ठीक है, ln y is equal to ln m plus ln e power kx. This equation would be written like this. Why? Because log of a into b is equal to log of a plus log of b. This is a standard formula in mathematics. ठीक है, so ln m plus ln e power kx. ठीक है, now this equation would be written as ln y is equal to ln m plus kx ln e. Why? Because log of a power b is equivalent to b log a. So this power has come over here. Now the above equation would be written as ln y is equal to ln m plus kx. Why? Because log of a to the base a is always 1. Over here I am finding the log of e and base is also e. So this number will become 1. So what is the final answer? Final answer is this answer. क्या ये अब लीनियर हो गया है? देखो जरा कंपेयर करो. Compare this equation, equation number 2 with equation number 1. देखो जरा. So can you notice mx is mapped to your kx and c is mapped to your ln m. If m is a number, then ln m is also a number. Am I right? Correct. And this k was obviously a number, and this k is acting as your slope. So basically, by taking your log transformation, a non-linear data can be transformed into linear. And we already know the advantage of linear. Taking business decision is easy. ठीक है, प्लीज ये 2-3 लाइन नोट कर लो and we'll end the session. The session over here, and I hope people have learned few new things today. नया सीखा नहीं सीखा? ठीक है, घर जाके उसे रिवाइज करना प्लीज. जो लोग घर में है वो घर में, ठीक है, एंड ट्राई रिमेम्बरिंग इट. Okay, so with this, I'll end the session. Thank you for joining. Can I remove it and share it? Okay.